Good morning, good afternoon. It's a few minutes before our start time. We will give other attendees a minute or so to dial in and join the webinar. Just enough time to fill your water bottles or coffee and get settled. Thank you for your patience. Good morning and good afternoon, everyone. I am Cynthia Perez, Director of Education at UTC. On behalf of UTC, welcome and thank you for being part of this webinar. Using technology to effectively and efficiently manage poll attachment requests, Part 1. Please note that attendees will be muted for the entirety of this workshop. However, we will unmute everyone at the beginning. And also, you certainly have an opportunity and encouraged to ask questions. We ask that you submit your questions through the Q&A function, not the chat function. The chat function will not be monitored for questions. Please note that the Q&A function is intended for webinar-related questions and content only. Please note that after the webinar, you will receive an email from UTC that will contain a link to the webinar evaluation form. This is very important. You must complete the evaluation form to receive a certificate of attendance. You will earn 1 professional development hour for this webinar. The slides and recording will be available in networks within 72 hours. And finally, today's presenter, Ron Bilodeau, Director, Strategic Solutions from Osmos, will present the webinar, followed by a brief Q&A session. Type your questions as you think of them, and we will answer as many as we can. Remember, use the Q&A function to submit the questions. I'm happy to introduce Ron Bilodeau. Ron, it's all yours.
Oh, thank you, Cynthia. I appreciate that. Thank you, everyone, for attending today's webinar, the session on poll attachments, using technology to effectively and efficiently manage attachment requests. It's that time of year. A lot of people are not attending webinars, so I'm grateful for the small group that we have today. And since it is kind of a small group, I think I'd like to go around, if we could, to kind of do some introductions, maybe gauge your experience in joint use, how many years experience you have in joint use, and then maybe try to get an idea of what you would like to get out of this session. It's a 2-part series, and the first part is really a lot about the basics of polls, the basics of poll loading, attachments, codes, regulations, that type of thing. And we're really not going to get into a lot of the data collection technologies, the online portal type of technologies, all the joint use management stuff until the next session. So I'd really like to kind of understand, where you are right now. So if you wouldn't mind, I think Cynthia's unmuted everyone. So if I call your name, maybe you could just introduce yourself, your years of experience, what you would like to get out of this session. It's kind of going to be an informal session today since it's such a small group. So Claudia Duarte.
Yeah, she have to unmute herself. Claudia, you should be able to unmute yourself.
Hello, can you hear me?
Yeah. A little bit of echo, Claudia, but I can hear you.
Yes. I don't know what's happening.
Do you have two devices on? Do you have your computer and your phone?
Yes, can you hear me now?
Still a little bit of an echo.
I'm not on.
Yes, now.
That's
Okay,
good.
let me try again.
Kind of fun.
Yeah, I'm sorry.
Okay, Claudia, we're just going to put you on hold for a minute and see if I know Eric's with UTC. Thanks for joining, Eric. And I will hopefully, I don't know if I'll see you tomorrow in Chicago or not.
No, I'm sorry. I won't be able to get there.
Well, thanks for attending the webinar today, Eric. Joshua? Joshua, are you able to introduce yourself, jump online and introduce yourself?
He unmute himself, so he should
Okay.
talk.
Well, you know what? Maybe since we're having a little difficulty here, and we only have an hour, maybe I'll just jump right into the webinar and the presentation here. Let me just get something squared away here. My mouse doesn't seem to be connecting with my wireless device. There we go. So I'll just, if you could just put everybody back on mute. It looks like everybody is on mute. And we will just go ahead and start with the webinar. Again, thank you for attending. This is a really interesting time for joint use management. And I'm assuming that most of you are in joint use management. Go back to this. Okay. So like I said, we're going to talk, this is a roadmap for today. I want to talk about the basics. I want to talk, well, the introductions didn't work out, but I'm pretty sure the rest of this will work out. I want to talk about poles. There's a lot of poles in the country, about 150 million poles in the United States. A lot of those are wood distribution poles. And then we're going to talk a lot about wood distribution poles. I want to talk about some of the design basics, talk about pole loading, attachment loading, and then go into some of the codes and regulations that drive the construction operations and maintenance of utility infrastructure. And talk a bit about some of the joint use regulations that create policy, right? Administrative policy, how you, what are the reasons you can deny an attachment? What are the accepted practices? What are some of the rate structures that are mandated by certain regulatory agencies? And then once we get through that, we'll talk a little bit about applications and an introduction to data collection technology. But I think by the time we get past the, this joint use management basics, we'll be pretty much on top of our hour. So I'm going to move on, but a little bit about my experience. I started my career as a cable television installer many, many years ago, 4 decades ago. And I got into cable television construction and building a lot of cable TV systems across the United States in the 80s and 90s on line crews. I was a telecommunications lineman, supervisor, foreman. And then in 2000, I came over from the dark side. I worked for an investor-owned utility, NV Energy in Las Vegas, Nevada. I managed their joint use program. I built a wireless co-location business for them, spent some time in demand side management, and then spent the last 5 or 6 years of my career there managing the reliability programs, all of the overhead and underground rebuild programs, the pole test and treat, the underground cable injection, most of the inspection programs and that type of thing. I've been with Osmos for about 4 years in a industry-facing business development role, and glad to be here today. So This is what we're going to talk about today. So I always like to start with the basics. Many of the attachment requests that you're going to see are going to be on wood distribution poles. I'm sure that you're receiving many requests to attach to your poles now, or you most likely wouldn't be on this webinar today. This wood distribution pole is the background or the backbone of the nation's electric infrastructure, electric and telecommunications infrastructure. It's the workhorse, the tired old distribution pole. As I said earlier, there's about 150 million utility poles in the United States, and most of those are wood distribution poles. There's been a lot of innovations and improvement in materials, though, over the past few years, and you'll see a lot of steel poles in the distribution grid. A lot of times those steel poles in the distribution grid are just used as foundation poles where it's difficult to guy a dead end pole or side guy an angle pole. And a lot of utilities will set a steel foundation pole to take up the tension of the angle or the dead end. Concrete poles, you'll see a lot of concrete poles in some states. The state of Florida had a big initiative to replace a lot of their wood poles with concrete poles after a major hurricane. They went through a storm hardening project, and they chose a lot of concrete poles, a lot of concrete spalling, things like that. But concrete typically you'll see used as a streetlight pole, streetlight standard pole. And you also see steel poles, a lot of steel poles being used for streetlights to support streetlight standards. Polymer and fiberglass, you see those making, being under consideration in high wildfire areas. And wood laminate is, there's a space for that. And this wood laminate poles, glue lam type poles are making some inroads in the pole plant population. So there's a lot of different pole species, right? And a lot of the poles in the United States are placed or derived from the trees in the area where those poles are placed. So in the northeast part of the United States, you'll see a lot of Norway pine or red pine. That tree grows there. In the southeast, you'll see a lot of southern yellow pine, and southern yellow pine makes up a majority of the population of the nation's pole. About 70% of the poles in the United States are southern yellow pine. On the West Coast, up in the Northwest, you see a lot of Douglas fir. You see a lot of western red cedar in Northern California, in Nevada, where I'm stationed. You see some lodge pole pine out here. So most of your poles are southern yellow pine, followed by about 15% Douglas fir. Immediately following that, you'll see more western red cedar than lodge pole pine or red pine. So those are the species of poles that you'll see in the United States typically. But regardless of the species, poles of the same length and class have similar load carrying capacities. And it's really important to, if you're managing joint use, to understand the load carrying capacity of a pole. But poles are extremely strong, wood poles especially. They have a tendency to flex, right? So when a load's applied to the pole, the structural members of that pole move, they bend, right? In the front of the pole, in the direction of the load, you'll see those fibers compressing, right? And in the back of the pole, the direction away from the load, you see those fibers stretching and tension being created along that back side of the pole. Those stresses in the fibers are designated as extreme fiber stress in bending. And wood poles also have what's known as a modulus of elasticity. So when that load on this pole here, when this load is removed, that pole has a tendency to deflect right back to its original upright position, right? So that's a modulus of elasticity. It's elastic. And if a pole deflects under that transverse load, of course, it would, the wind, when I say transverse load, I'm talking about wind being applied to the pole. The wind will deflect the pole this way. When it's removed, the pole bounces right back. That's one of the strong points of a wood pole. However, when you load those poles to a higher stress than the pole is capable of handling, then failure may occur. And that's what we're trying to avoid. So I think I just mentioned that poles have to be designed so that the bending capacity of the pole is not less than the load applied to that pole, or the bending capacity of the pole is, to say it a different way, is more than the load that's applied to it. The class of pole is determined by the circumference of the pole, right, at ground line. And this determines the amount of load that can be applied to that pole. The length of the pole is determined by the required clearances. At the pole, you need a certain separation between supply cables and communications cables. You need a certain separation between communications cables and other communications cables. And you need a height above ground in the adjacent spans that meets the code and creates a safe condition. So length determines the required clearance. So you want to select the class of the pole based on the load-bearing requirements. You want to select the length of the pole based on the required clearances. And then the grade of construction is determined by the location of that pole and the access to that pole. We'll go into that grades of construction a little later. So I know we have, I think the majority of us are from California. I'm in Nevada, but I spent a lot of time in California. But the National Electric Safety Code has been adopted in 49 states as the kind of the foundational book for construction, operations, and maintenance, geared towards safety of personnel and the public, right? Safety of workers and the public. The California is the only state in the nation with their own general orders, and they have their own rules for overhead, underground, substation, construction, operations, and maintenance, and they codify these in general orders. So in California, you have GO 95, and that's the overhead rules. And we'll go into those rules as we move through the webinar here today. So these are the types of attachments that we're talking about, right? Before we really dive into the poles themselves, let's talk a little bit about the types of equipment, wires, and cables that impact how we design pole lines. And if you're in joint use, you're really focused on those cables, right? On these communications cables down in the lower part of the pole. But in order to effectively license an attachment of, say, a cable TV line, you must understand, the electrical configurations in that. So here you have your typical three-phase circuit, A, B, C phase. There's three wires separated with an insulator on an arm. You have a fused cutout, so it's a fuse or cutout that can disconnect that single phase from the single phase transformer. Down below that, you have a neutral. This is where all of your bonding and grounding takes place. The single phase distribution transformer case is grounded to this neutral wire. This carries the return current from the primary winding of the transformer. You have a drop here that goes to the house. That can be a triplex, which is a spun or woven, a spun cable consisting of two conductors and a neutral, a load-bearing neutral, actually. And then you have, below that, you have your cable TV line. This depiction I pulled down, I think there's a mistake here. It says communications cable consisting of a telephone and 2 cable television lines. I believe this picture actually shows 1 cable television line and 2 telecommunication lines. The cable television line coax, and you can tell, of course, by this expansion loop right here. So I apologize, but I was looking at a different screen. 3-phase circuit, fuse cutout, transformer, neutral, triplex, cable TV right here, and 2 telephones right here. This is typically, your telephone is going to be your lowest attachment on the pole. Your next telephone would be here. Cable TV will be right above that. You can tell it's cable TV by this expansion loop. The coax is formed into an expansion loop so that as it contracts and expands in hot and cold weather, the cable's not pulled out of the connector at the active equipment. So when we're looking at poles, we're looking at three main directions when we're evaluating the load on a pole. We're looking at the longitudinal direction, right? That's that area, that tension between 2 poles that has a tendency to want to pull those poles together, right? Now, that typically takes care of itself, because if you have adjacent spans, cables in the adjacent spans, so if this cable continues through here, continues to the next pole, the weight and tension of the cables going to the poles in the adjacent spans will take up this tension and balance those poles out. If the poles, if it dead ends here, if the line ends here, and the line ends here, then that longitudinal tension is taken up by a down guy, which goes from the point of attachment to the ground, and that supports the, sorry about that, I moved my slide, and that supports the pole. They also use this a side guy if it's an angle pole. So if that pole line comes this way and the angle's this way, you'll have a side guy to take up that angled tension. So that's the longitudinal tension. And you also have the vertical tension. The vertical tension is the tension from the top of the pole to the bottom of the pole. And we really don't worry too much about that vertical tension, because that's, poles are really strong. And there's hardly ever a case where the vertical load on a pole will cause the bottom of that pole to blow out or break, right? Poles are very strong in that direction. So we don't concern ourselves much with vertical tension. What we're really concerned ourselves with when it comes to design and dictating, this is what dictates structure design, is this transverse load on the pole. So these conductors have a tendency to kind of have a sail effect. As the wind hits those conductors, and you've probably seen this in high winds, especially on poles with large conductors at the top. When the wind hits those conductors, it blows those poles. It causes them to deflect. The larger the conductors, the more conductors on the pole, the larger that sail effect. It's like unfurling a sail on a sailboat, and that's that transverse tension that we design to. So that's very important to know, and we're going to talk about some techniques that the cable television industry uses called overlashing, which really impacts that transverse load. So bottom line is, the bending capacity of the pole has to be higher than the bending load that's applied to the pole. And when you're designing a conductor or authorizing an attachment, engineering an attachment, approving a design for an attachment, you have to consider the fact that the environment has a big effect on that design. So in many places of the United States, the majority of the United States, there's a certain amount of ice that has to be applied to your design. So if you have a 3/4 inch fiber, and you're in what's known as a heavy loading district, and we'll talk a little bit about that in the next slide, I believe. You're in a heavy loading district, then you have to apply, your design has to include not just that 3/4 inch fiber, but that 3/4 inch fiber with a 1/2 inch of ice on it, and a certain amount of wind applied to that. Because as you double the diameter, the wire diameter, you're doubling the load on the pole. So if you have a 3/4 inch fiber and you add the 1/2 inch of ice on it, you're going to have 1.25 inches. You'll be close to doubling the load that's applied to the pole by that cable. And I'm going to talk a little bit about overlashing, but we'll talk about that a little later. And one thing that's interesting to note is that ice has a bigger impact on smaller cables. Applying the ice to a smaller cable, it has a bigger impact than on a larger cable. And you can see that, right? If you have a 3/4 inch cable and you apply a 1/2 inch of ice to that 3/4 inch cable, that cable becomes 1.25 inches. And that's a 67% increase in the cable diameter. If you have a 3-inch cable and you add that 1/2 inch of ice, you're only increasing the diameter of that cable by 17%. But you know, if you have a 3-inch cable up there, you already you should be doing some pole loading analysis to make sure that that cable doesn't that cable and the combination of the other equipment on the pole doesn't exceed the load bearing properties of that pole. So if you're managing joint use, you will see the impact of overlashing on your pole plant. I said I was a cable television construction, and we kind of pioneered the technique of overlashing because we were only allowed 1 foot of space and one attachment on the pole. If we wanted to expand our plant or rebuild our system, and back in the 80s when I was in early 90s when I was building cable TV plant, we rebuilt those systems a lot. You had to add a cable, and so the best way to add a cable was to take this lashing machine right here and pull a cable on top of the other cable and lash it up. This is actually an actual pole in Massachusetts. I took a picture of this pole. Not what we're trying to achieve here, right? Nothing like this. But there's quite a few places that exist out there like this, and proper engineering, proper auditing, and those type of things can avoid this. But when you overlash, you're adding an additional cable to an existing attachment. It increases wind loading, that sail effect I talked to you about. But it also impacts sag and telco separation. You can see that in the picture there. It can substantially increase the size of the existing cable bundle. And of course, that increases the diameter of the bundle, exposes more of that cable to the wind, and has an impact on the loading of that pole, the structural loading of that pole. We'll talk, when we get into policies next week, we'll talk more about the notification on overlashing that came out in one of the FCC orders, the One Touch Make Ready order. So as I said, construction, maintenance, and operation of electric and telecommunication systems are governed by different codes and regulations. In 49 of the 50 states, the National Electric Safety Code, or the NESC, has been adopted to ensure the safety of workers and the public. The state of California has adopted its own rules, which is codified in its general orders. NESC is published by the IEEE, the Institute of Electrical and Electronic Engineers. It's updated every 5 years. Most recent edition went into effect in February of this year. GO 95, or General Order 95, is published by the California Public Utilities Commission. Interesting thing about GO 95 is originally adopted in 1941 and originally enforced by the Railroad Commission. So I think most of you on the call are managing your joint use attachments under General Order 95. Here's a comparison of the two rules, the NESC and GO95. The purpose of these rules, while stated differently, is really the same thing. It's the safeguarding of persons, to secure the safety of persons, engage in construction, maintenance, operation, or use of overhead lines into the public in general. The rules, NESC rules are globally recognized. GO95 is recognized in the state of California. Personally, I did a lot of my construction work under GO95. It's a very safe yet forgiving order. And so I learned a lot just by doing a lot of work in California. I worked exclusively in California for 10 years. Interestingly, the NESC does not reference design. So the code actually states that it is not in section 1C. It states that the NESC code is not intended to be a design or instruction manual, and it only specifies what needs to be done for safety and how to accomplish that. In 2017, they however added a note to the NESC stating that the code is adopted by commission, boards, or bodies having control over design, installation, and operation of supply, communications, lighting. So they implied that while the code is not intended for design, it's used by individuals that actually do design these systems. GO95 actually mentions in it requirements for overhead line design, construction, and maintenance. So that's a small difference in those the two rules. When I say a small difference in the two rules, only in the purpose of the rules, right, as it's defined. So the codes are laid out. The NESC has 4 parts to it. They have the safety rules for electric supply stations and equipment, safety rules for overhead electric supply and comm lines, safety rules for underground electric supply and communications, and then work rules for the operation of electric supply and communication lines and equipment. So the overhead rules, the underground rules, really talks about clearances, spacing, loading, things like that. And you get into the works, the work rules, and that talks more about approach distances, confined space rules, and things like that. So that's how the NESC is structured. When I managed my joint use program, which I managed for about 10 years at the power company, I had a wireless co-location business where I put towers and substations and leased space on those towers to the telecommunications industry. Yeah, it was a pretty good business for the company, but I had to understand not just the overhead and underground rules, but also the rules for installing those towers in those substations. And I mentioned underground. In my joint use operation, we leased our spare primary duct to the telecommunication providers. General Order 95 is broken, or the general orders in California, really, when it comes to utilities, are broken up into 3 distinct programs. There's GO95, which is rules for overhead electric line construction, GO128, which is rules for underground electric supply and communications, and GO165 is inspection cycles for electric distribution facilities. GO165 is the newest of those orders. So I mentioned earlier that there's a big environmental impact, and just go to the next slide real quick. I think I got these. I got that one slide, broke it down into 2 different slides here. So one talking about the NESC and the other talking about. So let's just skip this one slide. This is kind of a comparison. The NESC is in most of the continental United States and Alaska and Hawaii, and GO95 covers the state of California. Geo95 has its own loading zones, and NESC has its own loading zones. So when you look at the loading zones, the environmental impact, there's 3 zones when it comes to the National Electric Safety Code. There's your medium zone, your light zone, your heavy zone. And in your heavy zone, you apply when you're designing your facilities or authorizing an attachment. The design includes 1/2 inch of ice and 4 pounds of wind per square foot applied transversely to the pole. So you can see why, right? It's where the Green Bay Packers play, the New England Patriots, the Buffalo Bills. A lot of cold weather teams play in that area, and you can expect you can expect longer winters, and you can expect that when it snows, that snow is going to stand those lines much longer. So that's why the heavy loading district has a 1/2 inch of ice. You look at the medium loading district, and this is kind of the Northwest down here through the southeastern part of the United States, upper Texas. You can see that, or kind of mid-Texas, you can see that you're only required to apply a 1/4 inch of ice and 4 pounds per square foot. And that's because you do expect cold weather, but shorter, winters. And you do expect ice and snow, but you expect it to melt much quicker. So they apply a 1/4 inch of ice and 4 pounds per square foot of transverse wind. When it comes to a light loading district, we're not applying any ice to the cable, right? It doesn't get that cold down here. You hardly ever see snowstorms in Southern California or in Florida. Interesting though, here in Nevada, we've had some snowstorms in Las Vegas before, but of course, like I said, very briefly, and no ice accumulated on the wires themselves, just a little bit of snow so that my kids could make a 1 foot tall snow person. But in the light loading district, you do, well, you don't expect any snow or ice. You do expect stronger winds. So where they don't mandate that you apply any ice, they do mandate that you apply a higher wind effect. So it's 9 pounds of transverse wind per square foot in the coastal areas and in those areas where you expect stronger offshore winds. California, it's separated by elevation, and in California, in the more mountainous areas where you do expect, where the ski resorts are, you do expect to see ice. They require that you apply 1/2 inch of ice. There's only 2 loading zones in California, heavy and light, right? In heavy, you apply a 1/2 inch of ice and 6 pounds per square foot of wind. And then in your light zone, you apply 0 inches of ice and 9 pounds per square foot of wind. So this is similar to the light loading district in the National Electric Safety Code. So once we get the structural capacity of the pole, and you understand the load that's applied, the cables, the equipment, you need to understand what grade of construction that you're using, so that you'll be using. So grade of construction goes from least robust to more robust. And in the case of the National Electric Safety Code, grade B is the most robust form of construction. Grade C is your typical, in the National Electric Safety Code, be your typical primary poles, typical joint use poles. Those will all be under grade C. And grade N, which I didn't include here, is typically for lift poles or drop pole going to a house where you might have a telephone drop, a cable TV drop, maybe a light conductor or something. But that's all grade N, and I didn't include that. Grade B, so as I said, grade C is for your primary circuits, your joint use circuits. Grade B is used with restricted access. So if it's a highway crossing or a railroad track crossing, or maybe a company's decided that they want to use more robust construction for say critical infrastructure, right? It might be a data center or what we call a TQS customer, a total quality service customer. A company might decide that for resiliency and reliability that they want to mandate grade B construction. And you can see the GEO-95 is somewhat comparable, right? But grade A is the most robust form of construction. Their safety factor is 4. And you can see it's comparable to grade B with a 3.85 safety factor right here. So this grade A is a safety factor of 4, comparable to grade B and NESC. Grade C, safety factor of 2 is comparable somewhat to grade C and NESC, and grade B is more of a middle grade of construction in California under GEO-95. And it's my belief that that grade B in California is going to be the grade of construction that's commonly used. So you got the pole, you got you understand your grading, you understand your loading zone. Now we have to talk about clearances, right? And clearances on a joint use pole. The pole is typically separated into 3 different sections: the supply space, which is the space from the top of the pole to the lowest electrical conductor or electrical equipment or component. Then you have your neutral space. Neutral space is also called the communication worker safety space. This is typically a 40-inch space between the lowest supply cable and the highest telecommunications cable. Then you have your communication space, and that is from the lowest, that's from the lowest point of the neutral space or the communication worker safety space to the lowest point on the pole that will provide the proper clearance above grade and the spans adjacent to the pole. That would be your telecommunication space. And then below that, including the section that's buried, is the unusable space on the pole. And I think we all know, if we've been in joint use management for a while, that there's really no such thing as an unusable space on a pole. So it's a little different in California. So I just put this slide up as a comparison because I know that most of the folks here on the call are from California. But under NESC, it's a 40-inch clearance between the lowest supply cable or conductor and the highest communications cable. And that lowest supply conductor could be an ADSS fiber optic cable, right? If there's not 40 inches between that, say this is a fiber optic cable and an ADSS fiber optic cable. We placed it right here, 12 inches below the neutral. If you don't have 40 inches between that and the highest comm cable, or it can be effectively reduced to 30 inches if certain criteria is met. But if you don't have that 30 inches, that now becomes the lowest supply conductor, even though it's an ADSS fiber. It's a all dielectric self-support fiber. It's non-conductive. It's still, if it's in the supply space, it's considered, when it comes to clearances on a pole, that lowest fiber is considered the lowest supply cable. And then when it comes to GEO-95, the typical clearances are 72 inches, 6 feet from the highest comm cable to the lowest supply conductor. Now, if you go 48 inches, so that's the minimum, you must install a guard arm above that highest comm cable. This gives the electric lineman a place to stand, right? So they're insulated from the telecommunications or from the telecommunications cable, the strand. They're not stepping on that. And it also provides a guide to let the telecommunications lineman know that that they're almost encroaching upon the supply zone. So why is this 36 inches or 30 inches or 40 inches? Why is it 40 inches? Well, it's because the typical lineman, this was explained to me when I was a lineman, I asked this question, why is it 40 inches? The typical lineman is, line person would be 6 feet, right? Typical, that's kind of the average. Look at the 6 foot person, and most telecommunications work is done above the lines. Whereas an electric lineman will use a hot stick. A lot of the work they do is above their heads, above their shoulders. As a telecom lineman, all the work is done at waist level, right? That lasher weighs about 70, 80 pounds, and you need to grab it around at waist side and transfer it to the other side of the pole. So if you take 6 feet, you cut that in half. That's 36 inches. Telecom lineman's working waist high. That's about 4 inches between they would contact. That gives a little bit of head space for the hard hat. So that's why they selected 40 inches. So if you're setting poles, you want to make sure that the poles are set properly, because sometimes someone will apply to attach your pole and the pole is just not big enough and not tall enough. So you may have to set a new pole. Sometimes if you've met the structural capacity of the pole, you're exceeding the structural capacity of the pole with a new attachment, you may have to set a new pole for the telecommunications company. And so when you set a pole, you typically set that pole 10% of the length of the pole plus 2 feet. And that's dependent upon soil conditions, of course. There are exceptions. If it's extremely sandy or rocky soil, you may want to bury that pole deeper. You're required to bury it deeper. But here's how it works out. If you have a 40-foot pole, 10% of that's 4 feet plus 2 feet is 6 feet. You're gonna have 6 feet embedded in the ground, 34 feet out of the ground, and that's what it looks like after setting a pole. So just a little tutorial on the different types of guys. We mentioned earlier, if you have a longitudinal strain on the pole, that in a dead end you have to guide that pole, or if it has a side guy or an angle, so if it's an angle like this, you would have to side guide that pole. And these are the different types of guys that you see out in the field. A side guide, as you can see, it takes the angle and counteracts that tension caused by that angle. And so typically, this is your typical side guy. Let me go back to this. It's your typical side guy. It's kind of what a down guy would look like too, right? If it was just straight down to the ground. This one seems, based on this picture, this is an angle guy. But the idea is to take that tension out. And now if you don't have, if this is street right here or sidewalk, you want to do an overhead guy, right? To cross the street. This would be a street here. So you'd guide this angle to another pole set on the other side of the roadway or waterway, whatever it may be, specifically so that you can place a down guy to take up that strain. A lot of sidewalk guys out there, this is if this is a street out this way and you still need to dead end or guy that pole or angle guy that pole, you can place a sidewalk guy with a post known as a queen's post in kind of a vernacular it's used, but it's a side guy post to use the proper term. And this post provides a proper clearance above the sidewalk for a pedestrian or someone who is riding their bicycle and probably shouldn't be on the sidewalk, but maybe. And then a strut guy, this does not provide support for the pole itself. This just provides the pole from bowing in the middle. But the idea here, the engineer believes that whatever tension is placed on this pole from these cables or conductors this way is not going to move the pole, but may have a tendency to bow that pole here. A push guy is used if I cannot guide the pole this way to take up the angle, then I set another pole and I push on the pole instead of pulling on it. I push on the pole to keep that pole upright to take up whatever tension or angle is in that that lead. They got some of these in Seal Beach, California, along Pacific Coast Highway, where they the pole line follows the water, and so you can't guy out into Anaheim Bay. So they have these push guys which support those poles. I actually had to climb up the push guy one time and then climb back down to my cable TV line. And then once your poles are there, you want to tag them, right? You want to be able to identify the poles. So there's different utility pole markers. You have your warning labels. You have your reflection numbers on your transformers, identifying the transformers. You'll have a tag here which might say that those transformers have PCBs, which has been determined to be a carcinogen by the state of California, like most things in California. And you know what? Safety first. Then you might have utility company ID tags, defective pole tags, and your identification tag. This is the first pole, I believe, that was placed in that system. It looks pretty old. If you see this tag, if you see, so, yeah, I didn't go through that again. High voltage, transformer signs, PCB labels, utility company tag, defective pole tag, and pole identification tag or sequential number tag. This pole was placed quite a few years back, it looks like. It looks like it was the first pole in the system. If you see a tag like this, that's typically an inspection tag. That'll tell you when that pole was inspected, when it was treated with preservatives. This is known as a nail tag. That's the height of the pole, 50 feet. These tags are important, right? And you want to instruct your joint use, your attaching entities to look out for these poles and for them to realize that if they see one of these red tags, they're probably going to have to wait for that pole to be replaced. The first tag, just an arrow saying proceed with caution, right? Something's been identified on this pole. Could have been a hollow, a sounding, identified a hollow spot or something. But it's not hazardous enough to not climb the pole. If you have that same arrow with an X in it, it's do not climb, right? Don't climb it, be prepared to replace it. And then if you see this tag here with the pole with the X in it, says do not climb, that the pole is going to be replaced. So we're getting very close to the end of the webinar for today. I'm gonna see where we end up here. Lines and wires. There's a lot of different types of lines and wires on poles. It's kind of, you need to know the characteristics of the lines too. You might look at say a cable TV coax. Well, that's a big wire sometimes. We used to install 1.25-inch coax lines, but really it's not very heavy, right? The coax is a very thin aluminum jacketed cable with a foam conductor with a aluminum center conductor that's copper coated. Very light, but it does have a high exposure to wind, right? Copper, it's heavy and high exposure to wind. You look at your fiber optic cables, they're small, but when you apply ice to them, if it's required in the area where someone's attaching, it gets much bigger. And then lead cables, don't go near those, but there's still quite a few lead cables out there. And they're typically the old incumbent local exchange carrier telephone cables. All this equipment's going to be on poles, right? And it's going to impact your attachment requests. One thing that you're going to see more of, and you're probably seeing more of, is antennas being attached to distribution poles. With it started with microcell deployments. It morphed into distributed antenna systems, and now it's small cells. And you'll see that they can be attached on the top in the supply space or in the comm space on a pole. And then I think, let's see. Yep, I think it's a good place to stop. Is going to be right here on wireless attachment standards. So if you're authorizing wireless attachments to your pole, you really need to understand that there are rules to make the wireless attachments safe, right? It's non-ionizing radiation. Someone can expose themselves to it for a certain period of time. The soft tissues in the body heat up. You can leave and come back and re-expose yourself. It's not like the sun or other types of radiation, X-rays and things like that. It's non-ionizing compared to that ionizing type of radiation, which is cumulative throughout your life. The non-ionizing radiation, as I said, can be safely installed on utility poles, but you have to make sure that it's installed so that those who are unfamiliar, those who do not work on wireless facilities, are protected. And it can either be by the physical construction, or you can have a cutoff switch installed on those wireless sites that's that anyone can have access to who works on that pole. But if you're interested in looking at the rules, the FCC's OET 65 is a baseline rule for installing wireless facilities. It creates it just goes through the clearance specifications so that no one's inadvertently exposed to that non-ionizing radiation, and of course the OSHA RF safety rules apply. Then when it comes to antennas, they can either be installed down here in the communication space, or they can be installed up here in the supply space. And if they're in the supply space, then qualified worker rules apply. So this work must be done by a qualified electrical worker. So anyways, I think that puts us at a point where we have 5 or 10 minutes for questions. Next week, what I really want to go through is all of the joint use policy and then just dive right into the technology. But right now, what I'd like is if we could unmute everybody and we could discuss maybe what you would like to see next week, you hear about next week, and I'll answer any questions you might have on today's webinar.
Well, Ron, this is Eric. I'll get the first question in.
Okay.
This is really, interesting because I'm not an engineer, right? But I know a little bit. But I just want to point out that next Wednesday, the FCC will vote on a new report and order, declaratory ruling, and further notice of proposed rulemaking on pole attachments. And that will, if it is voted the way the public draft looks like, then that will be, a valuable and balanced approach to, as the FCC says, modernize the pole attachment process. So
yeah,
more next week.
That's next Wednesday, huh?
Yep.
So it's too bad our webinar wasn't on Thursday. We could spend more time talking about the impacts of that. But truthfully, the FCC is the Federal Communications Commission, right? The rules that they codify in their regulation is rules that are favorable to deploying broadband. Fortunately, we have over the past 10 years, have had a lot better input to the FCC. The utility organization like UTC has been able to raise some safety questions with the FCC. Hopefully those rules, they're meant to speed up the deployment of broadband. And I think all those rules can be worked through, just like the one-touch make-ready rule, right? You have to apply more time, more effort. One-touch make-ready. Take that specific rule, the wireline accelerating wireline order. It allows an attacher to overlash without applying, just providing notification. But in that notification, it doesn't say that the utility can't require that anyone attaching to their poles does a pole loading analysis, right? And the National Electric Safety Code itself and GO 95 requires that those things are followed. So you just have to work through them like anything else with good communications, good understanding of your business and what you're there to do, which is what are you there to do in joint use management, right? You're there to increase cost recovery for your ratepayers, to ensure the safety of the workers and the public, right? And to not impact your core business, right? If you're an electric company, not impact the delivery of electricity. If you're a incumbent local exchange carrier, a telephone company, not impact your network's 5 nines of reliability, whatever that may be. So that'll be interesting to see how that all plays out, Eric. But with the proper administration, the proper knowledge, it'll work out.
Right. I think we were particularly relieved that in that declaratory ruling, they said, they clarified the whole red tech pole issue, that's needing replacement, and that would not be something that utility that the attacher would be charged, and they didn't define that necessitated solely by an attacher. They just gave some examples, right? So they didn't make it all prescriptive, and and in the FNPIM, we'll see whether that works out, because if that goes through like this, I think we would be we pretty satisfied. There is no perfect order, right? But this is something that would definitely help, would definitely deny the NCTA and the cable companies from like pushing through their wish list and making life hell for the utilities, and push all their expenses into the ratepayers invoice, and that's not fair.
No, it's not fair. And that same ratepayer, that same electric ratepayer, is that same telecommunications ratepayer, right? So at the end of the day, everybody on this call, regardless of who sends you an invoice, everybody's going to have to pay for that one way or another, right? Either through higher electric rates or higher telecommunications rates. It's all depending on what camp you're in, right? Our goal is to maximize rate recovery for, if you're a pole owner, maximize rate recovery for your investors, right? Your ratepayers also,
right.
And to make sure it's done safely and reliably. And I think the key point where the focus should be is on safety and reliability, right? At the end of the day, all these rules are made, but there's still the ability to deny an application for reasons of safety, reliability, and lack of capacity. And I don't think that will ever change.
Let's hope. If they do something with Section 224, I think that would be real trouble.
Yeah. Well, you keep marching up there to the hill, Eric, and take care of that for us, all right?
I will.
Take that. Any comments on any questions on today's, and any comments on what you would like to cover next week? If you want to just put it in the chat, or email me any topics or things that you'd like to cover next week, because I really wanted to but today was just a lot of basics, right? I really want to, once we get through the policy and regulations, which, we're not going to spend too much time on, I really want to drill down into, what it is that we might have been missing today that you're interested in next week. So if I don't have any questions, we're at the top of the hour, a little past. I'll go ahead and, well, thank you for attending the webinar this morning. And I will look forward to next week. And hopefully I'll get some feedback from you. And we can kind of have next week's session kind of directed towards things that you really want to hear. If I can have maybe 3 or 4 or 5 topics that we can drill down into, it might make it a really productive session for everyone. Cynthia, thank you for putting this together and all of the follow-up. And thank you everyone for attending on this Tuesday afternoon or Tuesday morning if you're on the West Coast.
I want to thank you, Ron, as well, and for a very informative presentation. And we'll see everyone next week for part 2. Have a good week, everyone. Bye, Ron.
Bye, thank you.
Bye-bye.